Good morning. There are three things today. There's the notes for today, today's in-class exercise, and then returning the in-class exercise from last time to you. So hopefully everybody's got that. We have a quiz next time. It'll be right at the beginning of class, so you'll want to be on time for that because we'll only have a very short amount of time available to take the quiz. Homework 3 is due on the 27th after we get back from the Eid break. And we're going to be talking more about interest today, specifically the effects of compound interest. So are there any questions before we move forward? Good morning. How are you? Here you go. So we're going to begin by reviewing simple interest, and that's what we've been dealing with so far, is talking about the amount of interest when we're not paying interest on the interest. And simple interest is just only take into account the principal and then the interest rate per period. And so as an illustration of that, it's the same kind of thing that we've been working with before, where if you know that the principal amount is 100,000, N is the number of years, and then I is the simple interest rate. And so you can see here that it's the interest rate per period, so every year 10%. So at the end of 3 years, when it's simple interest, all you have to do is multiply the number of years by the interest rate per year. Now, this is different from that kind of complicated example that we did previously. That was starting to give you the first idea of the effects of compounding. And so compound interest, which is what we touched on during that little more complicated example the other time, the interest is based both on the principal and the accrued interest. And so here's the big difference. Accrued interest. That means that after 1 year, you owe whoever's loaned you money the principal amount that they originally gave you, and you owe them the interest for that year. But then the following year, you have to pay them interest not only on the principal and the interest rate for that year, but also the previous interest that you hadn't paid them. And so if we're going to use a formula for that, this formula comes from the text, and it's a little bit complicated, and so let's make sure that we understand what it says. This is talking about the interest that's due from just one time period. If the time goes from 0 for however many years, time starts at 0 and it's going, and then it goes to time j. It goes to time t, which is t minus 1. Where's the eraser? Okay, so in this example, it's saying that time goes to t minus 1, and then it goes to time t. And so here in this, we're saying that the interest rate for only the last time period, if we had a cash flow diagram, we're having 1, 2, 3, and so on, t minus 1, and then time t. The interest that's due at time t, you have to know the cumulative interest for all of the time periods from time 1 until the second to last time period, add that to the principal, and then the interest rate per period, multiply the entire amount by the interest rate per period, and then that gives you the interest for time t. So if we take the same example of $100,000, when it was simple interest, what was the total interest amount that we had to pay in the previous example? $30,000. Well, $30,000 was the interest, and the total amount we had to pay back was the principal and the interest. So yes, $130,000. Okay, so this is the compounding example. And so we take it step by step, and we find out the amount that's due at the end of year 1 is $110,000, because there's the principal you still owe and the interest amount. But now the interest in year 2 is bigger than the interest in year 1 was. Now we owe $11,000 for that year, not only $10,000, because the bank looks at your balance and they say, this person doesn't owe $100,000 anymore. Now they owe $110,000. So they're going to pay us the interest on the total amount they owe, not just only on what we originally gave them. And so the interest amount is $11,000. You add that to the previous balance, and it's $121,000, and so on. So for 3 years, the difference between simple interest and the compound interest, you can see you're paying an extra $3,100 if the bank was compounding. So let me ask you a question. If you are loaning money, do you want to charge simple interest or compound interest? Compound, because you're going to get more money back. What if you're borrowing money? What do you prefer? Exactly. You have the idea. Very good. So there are specific terms that are used to distinguish between simple interest and compound interest. And the way to do it is to call nominal interest the simple interest, and effective interest is the word that we use for compound. And so nominal interest is when the effect of compounding hasn't been factored into the interest rate that is quoted. So an illustration of that is if a credit card charges 16% per year, but then it's compounded quarterly, the bank is trying to make it seem like the interest rate is lower than it really is. And so the bank would say it's 16% per year. But then if they compound quarterly, then the effective interest rate is going to be higher than that. And so the way that it works for the effective interest is you have to find out the interest rate per period. And so if it's 16% per year and they compound quarterly, quarterly means that every year they're going to calculate how much you owe, and then they're going to start charging you interest on the new balance. And so 16% per year divided by 4 means that every quarter the effective interest rate is 4%. This is the formula that you can use to convert between effective and nominal interest rate. And just to illustrate, let's take that same 16% and find out what is the effective interest rate for the nominal. Nominal is 16%. And so here, the R, the nominal interest rate per year, R is 0.16. The M is the number of compounding periods, and in this illustration we want to know if it's compounded quarterly, then that means that there's 4. M equals 4. And so we want to find I, which is the effective annual interest rate. So I is going to be 1 plus 0.16 divided by 4. And then that entire expression is to the m power, so that's to the 4th, and then minus 1. Everybody has calculators today, right? Will you calculate and tell me what is the effective interest rate if this is compounding quarterly? $1,699, right? So effectively 17%, right? So well, we could just say 17%. So it's not really a trick. They don't do it only because the bank is always trying to trick people, but it does look better if you can say your credit card has 16% interest instead of saying your credit card has 17% interest. Any questions about this? Yeah. Sure. The nominal interest is the rate that's quoted on an annual basis. So I guess the way that I'd say it is, let's put the labels on here and then see if we can go backwards and find a good definition. Okay, so this was effective. The 17% was effective, and the 16% was nominal. So nominal is the interest rate without the effect of compounding, and effective does include the effect of compounding on the interest rate itself. Okay. Are there other questions about this? All right. We have an in-class exercise, and so let me hand that out to, oh, you've already got them, right? Okay, that's right. Yeah, so we've got 4 problems on this in-class exercise, and on the first 2, you're going to be using a ratio. I've given you the formula here in terms of a ratio, and so I'm interested to see, I think you'll be able to figure that out, but I'll be circulating around if you've got any questions. I've got the solutions here, so work with a partner, and let's see how it goes on the in-class exercise. All right, let's try and take a look at some of these solutions. I think everybody's headed on the right track from what I've seen so far. On the first one, we're putting 25,000 dirhams into an account that pays 6.5% per year. Now, it's important for us to distinguish between the number of periods and the number of years. And sometimes it's the same. If it's compounding annually, then the number of periods and the number of years is the same. But if it's compounding monthly, then the number of years and the number of compounding periods won't be the same. But on this first one, it's just the N is 30 years. And so remember that the English language translation of this, this thing here, where we have F to P, I% and N, what we'd say is that the ratio of the future amount to the present amount for 6.5% and N equals 30 years, the ratio is going to be this 6.6143. Now, it's important not to round off too early, because you're going to report your answer. Let's see how many digits we've got in our answer. If the final answer is 165,359.15, that's 1, 2, 3, 4, 5, 6, 7, 8. And so we should have 8 digits. Now, I've rounded it off on the paper, but I kept it in my calculator, all the digits in the calculator. So don't say 6.6 is the ratio, because if you say 6.6, then everything after the first 2 decimals here is going to be different from the actual answer. And so we're dealing with real money, real amounts, and so it needs to be accurate to the last fill. If your bank statement, think about how upset you'd be if your bank was rounding off every time. If you took out 800 dirhams and they say, well, that's about 1,000. We'll just minus 1,000. If they were rounding off, you'd be furious. And so keep all the decimals while you can. So we calculate the ratio, and I think some of you mentioned you've seen this formula before, where it's 1 plus I to the power of how many compounding periods there are. And we got 165,000 in the end. Now the second one is the same formula can be used, but instead of solving for F, you're solving for P, the present amount. Again, this is compounded annually, so we don't have to worry too much yet about the difference between the interest rate per period and the interest rate per year. So it's just solving for the reverse of that ratio. And we got 52,750 and 13 fills. Any questions about the first 2 problems? Seeing so many of these problems like you are every class period really gets you ready for the quizzes and the exams, because You know, I think in the same way whether I'm writing an in-class exercise question or whether I'm writing an exam. So you're going to be very used to the way I write my language, the type of problems I give you. So hopefully there won't be any surprises on Thursday when we have the quiz. It's going to be the same kinds of questions. You got a different answer? Yeah? By how much? You got 751? 52, 751.24? Well, one of us must have rounded off a little bit. I hope I didn't make a mistake. You rounded off. Shame on you. No, it's okay. Yeah. All right. I'm using a different calculator this semester. I left my good calculator back in the United States, and so I always am a little bit paranoid that I'm making a mistake because I'm not used to my calculator. The buttons don't press the same way that I'm accustomed to. Yeah? Yeah, the quiz. Yes, it will be problem solving. I wouldn't say not theory because I might ask you a comprehension question. Maybe I would say, explain the difference between nominal interest and effective interest. And so you'd have to explain in your own words what's the difference between nominal. You know, that's the short, it's usually a short answer. That if I did have a theory question, it's usually a short answer that I'm asking you for. Yeah?
Up to this class exercise,
that's right. Including everything in the semester until today, and including today. All right. Okay, question 3, it's starting to get a little bit more complicated because the effect of compounding on a monthly basis is what we're taking into account. So it's like you're comparison shopping between two different savings accounts. One bank says that they have the higher interest rate, and the other bank is saying, well, our interest rate is lower, but we compound monthly. And so you know about compound interest, right? And you're saying, oh, yeah, of course I know about compound interest. So they're saying, even though our rate's a little bit lower, 7.25%, since we compound monthly, you should choose our bank. So the question isn't, is compounding monthly better, but which is going to pay you more? That's the full question that needs to be asked. And so you look at Plan 1, how much you'll get if you choose Plan 1. So it's just annual compounding. We're using the same formula as before, 257, 628.94. Now in Plan 2, since it's annual interest, don't let that trick you into forgetting that you need to compound monthly, because still they will say annual interest, but then it says right after that compounded monthly. So you can see that I is the interest rate per period. So what is the period? Is the period a month, a year, a day? You need to look very carefully at the problem statement and see what is the period. And here the period on Plan 2 is per month. So there's 12 of them per year. So N is 120 for a 10-year period. I, the interest rate per period. Here's our interest rate per period. And you can see in the end, Plan 1 is better because even though Plan 2 has compounding every month, meaning they pay interest on the interest every month, it's not enough to make up the lower rate that they're offering. So you make 99 dirhams more if you choose Plan 1. Okay? And then here's the last one, looking at credit cards. The same rate, here's the nominal interest rate, 24%, but depending on whether the bank is compounding quarterly, monthly, daily, you can see that the effective interest rate goes up. The more often they compound, it keeps going up. Any questions about either of these last two? No? All right. Yes? Well, more is better. Yeah, more is better. But you don't have to go crazy. You know, sometimes it wouldn't make sense. There's an implied precision in finance that isn't necessarily implied in other fields. You know, like we carry money to the last, to two digits afterwards. You know, you can have one fill, but you can't, someone isn't going to pay you a tenth of the fill. And most of the time, actually, they round up, you know. But I think 2 decimals is good for most of the things that we're doing in the course. All right. Let's look one last time at our announcements. So you have with you now homework 3, right? I've given that to you already. Has anybody already started on homework 3? Okay. It's always a good thing to start early because I'm not going to be around during the Eid vacation. I'm going to be in India. So I won't be checking my email. So if you need help on the homework, you know, you already know everything that you need to solve that assignment. So if you get an early start, that'll give you a chance to ask questions if you have them. So when we get together next time, the quiz will begin right at 8 o'clock. We'll only have about 10 minutes for that. So it's important to be on time on Thursday. I will see you then. Have a great day.